Hello, good morning, friends. Good morning, everyone. So, we are here for the 23rd lectures of this series of environmental engineering in the channel Just Get Civil, and we are going for actually welcome to this Mission Gate 2021. And myself, Soumyajit Sen, we are discussing regarding a crash course of environmental engineering. And we have already done with the 22nd 22 lectures of this series, and here we have already done up to the problems of first problems of this coagulation flocculation. First we have discussed all the chapters theoretically, and while discussing all the chapters theoretically, we have gone through the certain chapters we have already done with the problems itself. फिर से मैं लौट के आया था जो सब टॉपिक का रिकैप उसके साथ प्रॉब्लम्स बनाने के लिए, और उसमें डोमेस्टिक वाटर सप्लाई में क्वालिटी ऑफ वाटर, प्लेन सेडिमेंटेशन, कोआगुलेशन, फ्लोकुलेशन और फिल्ट्रेशन का कुछ पार्ट ऑलरेडी हो चुके हैं. So let's see. And just before starting the process of our discussion, just a reminder that if you don't have the Unacademy learning app in your app or mobile, then go to the Play Store of your mobile and install the Unacademy learning app. You please install this and go for the subscription of the Plus courses. Plus course is actually the first stepping stone for your desired exam which you need to crack. If you are going subscribing for a Plus course, then you will get a personalized mentor, and the mentor means a coach. एक coach ऐसा coach जो ये सारे प्रोसेस से गुजर चुके हैं, उनको मालूम है कि क्या स्ट्रेटेजी होना चाहिए, कैसे स्ट्रेटेजी आपको लेना पड़ेगा, एंड एवरीथिंग. तो आपका जो एग्जाम स्ट्रेटेजी होगा उसमें आपको हेल्प मिलेगा, आपका एग्जीक्यूशन में हेल्प मिलेगा, एंड ऑब्वियसली by this process you will achieve much better rank in your examination, in your target examination. Now while taking the subscription, don't forget to apply the code SEN10. While taking the subscription, don't forget to apply the code SEN10, ACN10. Don't forget to apply the code SEN10. Then good news है there, सिविल बैच के लिए जो 2022 के लिए दे रहे हैं, already we have started a batch on 28th December. Just a reminder, in English and Hindi both, and if you are subscribing for this batch, don't forget to apply the code SEN10, ACN10. Don't forget to apply this code SEN10. And 11th January 2021, this course is actually launched already for EAC prelims batch A. Another batch is launched, batch B, for both the cases. Don't forget to apply the code SEN10. And the good news is tomorrow's class, tomorrow, come 2 p.m. I will be live for a marathon session that I will discussing regarding how to boost your gate rank in 5 hours. In those 5 hours, I will secure 10 to 12 marks. That's my promise. Please be there. Don't forget to be there on the Just Get Civil channel. Marathon session will be there for boost your gate rank in 5 hours. And this will be a benchmark. This session will be a benchmark for you, for your process of preparation. I'm literally I'm promising you that in that 5 marks, in that 5 hours, you are going to secure 10 to 12 marks, 10 to 12 marks for your gate examination process. So we are continuing. Then we will continue with the problems on filtration. We've already solved certain problems on filtration. Rest of the problem we will solve today, and then we will move further for other chapters problem itself. Okay. Request 32 questions we have solved. So now today we are going to solve for 33rd question, continuation of the filtration problem itself. Question number 33. A city has to treat 24 mld of using rapid sand filter with a rate of filtration of 5 meter cube per meter square hour. Two questions are there. Determine the size of the filter bed if L is to B is equal to 2 is to 1, and only one unit is provided. B. Determine the percentage of filtered water required for backwashing the filter if rate of backwashing is 6 times the rate of filtration. If rate of backwashing is the 6 times of the rate of filtration and the duration for backwashing is 10 minutes, crossing is done once in a day. Please look at the question and try to solve it. ক্লাস নিচ্ছি, পরে কথা বলবো। So let's solve the question. So what is given here? So for this question, it is Q is given as 24 mld, right? So Q is given as 24 mld, and rate of filtration is 5 meter cube per meter per hour. So surface area of filtration, total surface area will be Q, that is 24 into 10 to the power 3, that part will be meter cube, by 24 into 5. So it will be 200 meter square, and only one unit is mentioned in the question. So quite obviously, and L is to be also provided as 2:1. So we can say that 2b square is equals to 200. So b square equals to 100. So b is equals to 10, and L is equals to 20 meter. Now that is the first part of this question. The second part, they're asking what is the percentage of filtered water used for backwashing. We know the formulation process. The percentage of filtered water used for backwashing is equals to volume of water used for backwashing by volume of water filtered into 100, and volume of water used for backwashing will be rate of backwashing into duration of backwashing into area by C by volume of water filtered is rate of filtration into duration of filtration into area. See how I am minimizing the calculation process. Try to understand. That is very important for your gate examination problem solving process. जितना ज्यादा आप कैलकुलेशन को, जितना ज्यादा कैलकुलेटर को कम यूज करोगे उतना ज्यादा टाइम आपका सेव होगा. गेट कैलकुलेटर, एंड डोंट यूज योर नॉर्मल कैलकुलेटर, ट्राई टू यूज योर गेट कैलकुलेटर. और टाइम नहीं है आपके पास इस सारे चीज के लिए. इफ यू आर नॉट यूजिंग इट, डू इट टुडे. Now rate of backwashing, it is provided as 6 times of rate of filtration. So 6 into ROF. Duration of backwashing is 10 minutes. 10 by 16 hour. And this area cancels by rate of filtration. In duration of filtration will be what? In 1 day, once backwashing is done, right? And the backwashing time is 10 minutes. So how much filtration is happening? 24 minus 24 hour minus 10 minutes. Understood? That is the trick of this problem. So ROF is gone. So it is 1 by 24 minus 10 by 60 into 100. The final answer will be 4.19 percentage. Final answer will be 4.19 percentage. Hope you understand. Have a look quickly on the duration of filtration. So 2-3 things are there. You have to be careful about the duration of filtration. You have to be careful about the minimizing of the calculation process. Okay. Let's go for the next question. Question number 34. A water treatment plant is designed to treat 0.25 meter cube per second of turbid water. Number of filter unit is equals to 4. Rate of filtration is 5 meter cube per meter square hour. Backwards rate 10 liter per meter square second. L is to B 2 is to 1. Determine option A, the length and width L and B, and option B, question number B, flow rate in wash water drop if 2 drops are provided. If 2 drops are provided. Solve this question. Let's solve. So Q is given as 0.25 meter cube per second. Rate of filtration is 5 meter cube per meter square hour. So surface area into 3600 by 5, that much meter square. To 110 meter square. So number of unit, it's 4. So area of one unit, 210 by 4. Sorry, it's 180 meter square it will be. Sorry. So 2b square is equal to 45 from here. B equals to 4.74 meter and length will be 9.5 meter. Now what they're asking? Flow rate of backwashing. So that is the first part. Second part you need to understand properly. They're asking Q backwashing. Flow rate having its rate of backwashing. You are having this. So rate of backwashing is unit is what? Liter per meter square second, right? What you need to multiply? You are actually aiming for Q backwashing. Q means volume per time. So just unit conversion process. You need to multiply area of filter. Understood? Sorry. So rate of backwashing is given as 10 liter per meter square second into area is 45. So it's eventually it is 450 liter per second. That is 0.45 meter cube per second. And that is the whole flow rate, and it will be divided into two trough. So flow rate through one trough will be 0.45 by 2, that is 0.225 meter cube per second. Okay. Clear? Let's go for the second question. Next question. Question number 35. In order to taste, a filtration process, clear water is made to pass through a bed of uniform sand at a filtering velocity of per hour. Sand bed has the following properties: depth of bed 0.6 meter, sand grain size 0.5 mm, specific gravity 2.65, safe factor is 0.8, porosity of sand bed during filtration is 0.4, and new coefficient of kinematic viscosity is 10 to the power minus 6 meter square per second. Calculate head loss during filtration. Calculate the head loss during filtration. Solve it. So let's solve the question. What you have to use? You have to use the Karman and Kozny equation, right? To find out this head loss. Where F is equal to 115 to 1 minus N by RE plus 1.75, and where RE is equals to rho VD by mu into 5, right? So that is the process. So first you need to apply this. Everything is given. So just writing the term. Actually, here though I write in L, it should be Z. Then you can understand the same thing. It should not create confusion. So here Z is what? Depth of filter, it is given as 0.6 meter. G we know 9.81. Diameter of sand particle is given as 0.6 mm, or no, 0.5 mm. 0.5 into 10 to the power minus 3 meter. Porosity given as 0.4. Phi is also given as 0.8. And this is velocity of sand bed, means actually the rate of filtration V. Rate of filtration is 3 meter per hour, which will be 3 by 3600 meter per second. Nu bar into rho W will be your mu. So I am not calculating itself, just writing the final answer. Final answer will be 0.216 meter. Just put in the formula itself, so that you can understand how to solve this question. 0.216 meter will be the final answer. Okay. Let's go for the next question. Question 36. A small filter of 0.05 meter depth removes 90% of particles present in water. If the particle removal efficiency is 99%, then what should be the depth of filter? Solve this. Let's solve the question. We know lambda is equals to 1 by z ln 100 by 100 minus eta. That is actually a form of I was the equation, if you remember, and your lambda is constant. That means lambda 1 will be equal to lambda 2 itself. So what we can say, 1 by z1 ln 100 by 100 minus eta 1 is equals to 1 by z2 ln 100 by 100 minus eta 2. Clear? So z1 is given as 0.05 ln 100 by 100 minus 90 is equals to 1 by z2 ln 100 by 100 minus 99. So 1 by 0.05 ln 100 by 10 is equals to 1 by z2 ln 100 by 1. It's ln 10 and ln 100. 1 by 0.05 ln 10 is equals to 1 by z2 ln 100. From here you can say that z2 is equals to ln 2 log. So actually it's 0.05 into ln 100 by ln 10. So it is ln 10 itself. To 0.1 meter. Okay. Let's go for the next question. Question number 37. It's GATE 2018 question. And I have repeatedly told you when we are actually going for the question, the discussion of that filtration process, that you need to understand the operation very carefully. Otherwise, you won't be able to solve the question. You will understand my statement. What is the truthfulness of the statement is, if you don't understand the operation properly, you won't be able to solve this particular question easily. And if you understand, it will be a cakewalk. A small water treatment plant features four filters. The rate of filtration and rate of backwashing are 200 meter cube per day per meter square and 1000 meter cube per day meter square. Respectively. Backwashing is done for 15 minutes per day. The maturation period is 30 minutes. It is proposed to recover the water being wasted during backwashing and maturation. The percentage increase in the filtered water produced will be. I'm giving you certain time. This question is very important to solve. Try to understand the statement and solve it. Now, so let's say, so try to understand the thing. What is told in this question? Small filter unit with just 4 filters. Rate of filtration and rate of backwashing is given. Now, what is maturation period? Immediately after backwashing, as the filter media is expanded, the water treated will not be of that good quality. So what we will do? We will, that particular time, certain time we will give to the filter media to, so that it can regain its initial phase. That time is called as maturation period. We have discussed it in the class. Here it is told that the whatever water generated from the backwashing and from the maturation period, it will be go to the filtration process once again. So see the solution process. Percentage increase in the filtered water is equals to volume of water generated from backwashing plus volume of water generated from maturation by volume of water filtered into 100. So that will be equals to, what is volume of water generated during backwashing? Its rate of backwashing into backwashing into area plus rate of during maturation in at what rate, during maturation, at what rate the things will happen. Obviously rate of filtration, because after backwashing the filtered water will not be of good quality due to the expansion process. So rate of filtration will be the point of concern. Duration of filtration into area by rate of filtration into duration of filtration. Sorry, it's duration of maturation. Sorry, not duration of filtration. Here, let me write down this into area. Into 100. So rate of filtration, duration of maturation. Is it clear? Now see, rate of backwashing is given as 1000 meter cube per day meter square by 24. I'm doing to convert it into hour. Duration of backwashing is 15 minutes So 15 by 24, sorry, 15 by 60 hour, and area will be same. So I am just cancelling it. Area term plus rate of filtration is 200 by 24 into 30 by 60 whole by rate of filtration is 200 by 24. The main point is the duration of filtration. So in a day, 24 hours day, 15 minutes is going for backwashing and 30 minutes is going for maturation. That time you need to deduct from the whole day process. So from here you can take that 24 will be the common factor, leave it. So it's 250 plus 100 by 200 into 23.25 into 100, it will be 7.526%. With 7.526%. Okay. So just have a recap. This question, what we have solved for the problems on filtration. Yesterday we have solved 32 questions, mainly theoretical and mainly mathematical questions we have solved today. So the types are covered actually. Here's the first question. So just a reminder that I'll be live tomorrow from 2 p.m. It's a marathon session. I'll promise you to boost your rank within 5 hours by ensuring 10 to 12 marks. Be there with me. Boost your get rank in 5 hours. It's a marathon session. We'll deal with 10 to 12 marks in those 5 hours. We will secure this 10 to 12 marks in these 5 hours. Now we will go for, so filtration is over completely. Now we will go for the problems on disinfection process. We'll go for the problems on disinfection process. So before going to the problems on disinfection process, we'll go for a recap of that disinfection process. Just the recap process: disinfectant, disinfection tank, residual sterilizing effect. We have discussed about the applied amount and what will be the demand amount. We have gone for the certain requirements before choosing the disinfectant. Then the mechanism of disinfection. Then we have gone for the methods of disinfection. Briefly discussed about all the physical methods. First, the temperature, heat by light. Gone for the equation for this UV ray treatment. Solved the question. Then chemical methods by applying calcium oxide, metal ions, ozone. Then we have entered to the halogen group of chemicals. Chlorination process, hydrolyzation reaction, ionization reaction, effectivity of chlorination, percentage of HOCl, concentration of HOCl, chlorine consumption process, chlorine applied, what is chlorine demand and chlorine residual chlorine concept, and different forms of chlorine, bleaching powder dose, chlorine dose, hypochlorite, chloramine, chlorine gas, and then chlorine dioxide. Then we've gone for the kinetics of chlorination, all those equations, Sixth law for disinfection, then type of chlorination. We have discussed in details the breakpoint chlorination. We have explained it. And free residual chlorine and combined residual chlorine concept here. Okay. That's the recap. Just going through the process, what we have gone through in the discussion. If you're remembering it, fair enough. Else, you need to go to the class of chlorination once again. Now we are going for the questions. Once again, a gentle reminder that we'll be live tomorrow 2 p.m. for a marathon session for boost your gate rank in 5 hours. 10 to 12 marks will be secured, which will take you around for 10,000 to 12,000 students ahead of. Let's go for the first question. It is required to supply water to a population of 20,000 at a per capita demand of 150 liter per day. Determine how much bleaching powder is required. In kg per day. If the chlorine dose is zero point 0.2 ppm, assume bleaching powder contains 30% of available chlorine. First question. So let's see the solution process. Population is 20,000 and the part category demand is 150 liter per day. So Q will be 20,000 into 150, or you can say it's 3 into 10 to the power 6 liter per day. It's 3 ml. Dose is 0.2 ppm. ppm means milligram per liter. 0.2 milligram per liter. So chlorine required 3 into 0.2 ml into milligram per liter, directly kg per day. 0.6 kg per day. So bleaching powder dose, its chlorine dose by percentage chlorine available. It's 0.6 by 0.330%. It's 2 kg per day will be your final answer. 2 kg per day will be your final answer. Let's go for the next question. Question number 2. Chlorine uses in the treatment of 20,000 meter cube per day is 8 kg. The residual after 15-minute contact time, 10 minutes, after 10-minute contact time is 0.15 milligram per liter. The chlorine doses and demand in milligram per liter will be read the statement, solve it smartly, remember the unit conversion process. Take your time. So let's see. So Q is 20,000 meter cube per day, is 20 ml, and chlorine uses is 8 kg per day. So we know that kg per day is what? ml into milligram per liter. I am just solving this question on the basis of the unit conversion. Correct? So 8 kg per day is equal to 20 mld into some x milligram per liter, where x is equals to what? 0.4 milligram per liter. So what will be the chlorine uses now? 0.4 milligram per liter. Residual, it's 0.15 milligram per liter. So chlorine demand will be 0.4 minus 0.15 applied minus residual 0.25 milligram per liter. That is second question. Hope you understand this. Question number 3. For a water, doses at break point is 1.5 milligram per liter. Doses as breakpoint is 1.5 milligram per liter, and residual chlorine and residual chlorine at that time is found to be 0.3 milligram per liter. If cumulative chlorine added is 2 milligram per liter, then the residual chlorine will be let's solve question number 3. So this question can be solved from the breakpoint coordination graph itself. So this is the plot. Ideal water line. So this is your breakpoint, right? So doses at breakpoint it is already told as 1.5 milligram per liter. So doses at breakpoint 1.5 milligram per liter, and at that time the residual is how much? 0.3. So combined chlorine residual. So at breakpoint the residual is nothing but the combined chlorine residual. Combined chlorine residual is 0.3 milligram per liter. And the after breakpoint applied is how much? Cumulative is 2, means total is 2. So after breakpoint applied is 2 minus 1.5 is 0.5 milligram per liter. So that's 0.5 milligram per liter is nothing but the residual, free chlorine residual. So free chlorine residual is 0.5 milligram per liter. So your total chlorine residual is combined chlorine residual plus free chlorine residual. It's 0.8 milligram per liter. That is your final answer. So 0.8 milligram per liter will be your final answer. Is that clear? The next question, question number 4. The equation given HOCl giving you H plus OCl minus K value provided as 2.7 into 10 to the power minus 8. Asked the 90% fraction of HOCl is available at a pH value of. Question number 4. percentage HCl is equals to 1 by 1 plus K by H plus, right? Into 100. So it's 90% HCl is available when 1 by 1 plus K value is 2.7 into 10 to the power minus 8 by H plus. So from here you can find out the value of H plus and asking the value of pH, which will minus log of H plus and concentration. That H plus value you will put there. Final answer should be 6.6. Final answer should be 6.6. That is question number 4. Going for question number 5. To obtain 99.7% kill of bacteria, ozone is to be used in water with a residual of 0.6 milligram per liter. The reaction constant is 3 into 10 to the power minus 2 second inverse. Calculate the time of contact required. So to obtain 99.7% kill of bacteria, ozone is to be used in water with a residual of 0.6 milligram per liter. The reaction constant is 3 into 10 to the minus 2 second inverse. Calculate the time of contact required. So we know that from the art of Chick's law for disinfection, eta is equals to 1 minus e to the power minus kt into 100. So 99.7% efficient. 3 into 10 to the power minus 2 into t into 100. From here is solve for t. It will be 192 second, which is eventually 3.2 minute. K value is given as 3 into 8 in second itself. Going for question number 6. Water contains ambient of coliform as initial after chlorination ambient decreases per 100 ml. The value of percentage R and log R. Solve this. Very easy to solve. Power 6 per 100 ml and NT is 100 per 100 ml, right? So first we are going for percentage R, that is N naught minus NT by N naught into 100. It's 10 to the power 6 minus 10 squared by 10 to the power 6 into 100. It is 99.99%. Log R is 6 minus 2 is 4. Question number 6. Question number 7. Available chlorine in bleaching powder solution 0.3 milligram per milliliter. To obtain a chlorine dose of 0.1 milligram per liter in a 200 ml water sample of bleaching powder solution to be added is four options are provided. The options are important, that's why writing the options. Four options are there. So to solve this, you have to keep the option in your mind. So chlorine dose will be how much? 0.1 milligram per liter. So 0.1 milligram per liter into 200 ml by 1000. And what will be bleaching powder dose? It's chlorine dose by percentage chlorine available. Here it will be 0.1 into 200 by 1000 into 1 by 0.3. So option D will be your correct answer. Option D will be your correct answer. So still important 4-5 problems are left. We'll solve this, but tomorrow we'll solve the day after tomorrow, 17th. Tomorrow is the marathon session. Tomorrow is the marathon session. Don't forget to be there. This particular session, in those 5 hours, your rank will be boosted. That my promise. And I am telling you, you will get a secure of 10 to 12 marks in those 5 hours. So tomorrow's live class, marathon class is very, very important. Don't forget to be there. I'll be live from 2 p.m. I'll be live from 2 p.m. There will be a marathon session where we will go for the boost our gate rank in 5 hours. Boost your gate rank in 5 hours. And just a reminder that if you don't have the learning app still, go for the Unacademy learning app and install it. Go for Get an EAC plus courses and subscribe it. While taking the subscription, don't forget to apply the code SEN10. Don't forget to apply the code SEN10. It will help you to get direct 10% discount in the enlisted values. You all for Get 2022 have already launched 2 batches for EAC prelims. For all the cases, don't forget to apply the code SEN10. Don't forget to apply the code SEN10. And again, I am telling you, please be there tomorrow from 2 p.m. I will live for gate rank, boost your gate rank in 5 hours. It's a marathon session. I'm promising you that 10 to 12 marks will be secured from that 5 hours itself. Thank you. See you tomorrow. And we will continue the solving process from day after tomorrow itself.